solutions of equations. We've already discussed expressions, how to write expressions, how to solve expressions. So today we're going to start with equations. The Common Core Standard is over here on the right, and it's reason about and solve one variable equations and inequalities. So the essential question asks, how do you determine whether a number is a solution of an equation? Well, a couple of key words that you need to know are equation and solution of an equation. There are three examples right here of equations, and you'll notice that each one has an equal sign. That's what makes an equation, and we've talked about how expressions do not have equal signs, and that's how you can tell the difference between an equation and an expression. So an equation is a statement that two mathematical expressions are equal. So that would mean that 8 plus 12, which is an expression, is the same as 20, which is an expression. When you put them together using an equal sign, that makes it an equation. So the same is true of 14 equals whatever a is minus 3, and with an equal sign, that makes that an equation. And then we have 2 times d equals 14, and with the equal sign, that makes that an equation. A solution of an equation is a value of a variable that makes an equation true. So in this example, we would be looking for what value of x, in other words, what number does x stand for, added to 3 would equal 5. So in the blue it says x would equal 2, and that would be the solution of the equation, because 2 plus 3 equals 5. So essentially what you'll be doing is plugging in numbers for variables. Another word for variable is letter. Moving on to the next page, in your book it would be page 295, under share and show. It says determine whether the given value of the variable is a solution of the equation. Now with these certain examples, it might be mental math for some of you. Others of you may need to work it out. In 7th grade, it's going to get harder, 8th grade, harder than that. So there will be certain things that will require of you in 6th grade when we're actually solving more difficult equations. But for right now, basically they just want to know if you plug in the number 7 for x, so basically if you plug it right in for x, is 7 plus 12 29. So you just plug the 7 in for the x. 7 plus 12 is 19. So does 19 equal 29? It does not. So you put a slash through the equal sign, and that means does not equal. So then on the line, you would just write not a solution. So 7 is not a solution for x plus 12 equals 29. Moving on to number 2. They want to know, is 15 a solution for this equation? So all you're going to do is plug the 15 in for n. So you plug 15 in, copy the rest of the equation. 15 minus 13 is 2, and 2 does in fact equal 2. So n equaling 15 would be a solution to this equation. Number 3, we have 1/2 times c equals 14 when c is equal to 28, and it's asking if that is a solution. So we have to take 1/2, and remember we had talked before that when you have a letter right next to a number, even if it's a fraction, it means to multiply. So I would typically put parentheses where the c would go, because parentheses next to a number also means to multiply. And then I would copy the rest of the problem, and where the c would go, I would just plug in the 28 in those parentheses. A couple things you have to remember here is when you're multiplying fractions, you multiply the numerators and you multiply the denominators, and then you try to reduce or change any improper fractions So we can reduce before we multiply. 2 goes into 2 once, and 2 goes into 28 14 times. There's nothing else to reduce. So we multiply the top. 1 times 14 is 14, and 1 times 1 is 1. So that gives us 14 over 1, which equals 14. So yes, this would be the solution. 28 plugged in for C would be a solution. I'm just going to show you one other way because we will be doing this a little bit differently. So I'm just going to take number 1 and show you another way that we'll be solving these. So I'm going to copy. I'm going to copy this equation twice, and I'm going to put it in a T-chart. And you can just listen to this and kind of look at it, rewind it if you need to. So basically what I'm taking is this equation right here. And using our mental math, we pretty much know that 7 more than 12 is not going to give us 29. But if we want to know what x would stand for, then we can solve it this way. And we've solved some equations this way or expressions this way before, where we've seen multiplication, so we've done division, and whatever we've done to the left, we do to the right. So this side of the T-chart is the solving side, and this side is the checking side. So to solve this, if I see addition, I'm adding 12 here, and I want to solve it, I would take 12 away, because I want x to be on one side by itself. I take 12 away. Whatever I do to the left of the equal sign, I have to do to the right. So now I have x by itself equals, well, whatever 29 minus 12 is. And 29 minus 12 is 17. So I have my real solution to this problem right here, that x would be 17. Well, now I want to check to see if that's true. So I'm going to plug the 17 in for the x on the check side. So I would have x plus 12 equals 29. Then I'm going to plug the 17 in for the x. And then I'm going to do the math. If I need to, I can come over here and add that up. And I see that 29 equals 29. So it checks. So that means that 17 is the value of x for this example. And again, this is just something we're going to be getting into later. And this is one way to check to see if you have the right answer, to see if you can find the solution to an equation. Okay, moving on to numbers 4, 5, and 6. I'd like you to try number 4 and number 5 and number 6 and see if you can come up with whether or not these following examples are solutions or are not solutions. So you might want to pause it right now and work these 3 problems out, and then check your answers with mine as soon as you finish. Good luck! Okay, well hopefully you were able to work out those problems. And I didn't want to give you any hints on those. I wanted to see what you could remember. I know we've had a week off from vacation, but hopefully you remember that when you add decimals, sometimes it's easier to rewrite them vertically, and remembering that when you add and subtract decimals, you line up the decimals and also line it up in your answer as well. So that was one thing you had to remember for number 4. Number 5, the same thing. Sometimes it's easier, instead of trying to subtract horizontally, it's easier to line it up vertically and line up those decimals. For this one you had to borrow, right? And still it comes up as 14 minus 8. Some of you still like to show this borrowing. So it's still 14 minus 8, so that is a solution. And number 6, hopefully you remembered that when you plug 7/10 in for k, you don't have common denominators. So in the past you've learned it is easier to go vertical again, and then you have to find the common denominators, which would be 10, and then you have to convert the 3/5 into 6/10 by multiplying by 2, and then 7/10 just stays 7/10. And then remember it's subtraction, so 7 7, 8, and 9, and we will check those in the morning. Have a great night, everyone.